Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilations in measurements. This is standard 8.10D in the great state of Texas, and we are using item number 1 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we'll look at our answers together. So we have a triangle dilated by a scale factor 4.1, and we need to figure out what does that do to the area and perimeter of the new triangle. So let's open up our graph draw feature, and let's go ahead and just draw a real quick coordinate grid, and we're going to just make some triangles to visualize this. Now, if you already know what happens to the area and perimeter of a triangle or any shape when it gets dilated, then this is a very simple problem. But if not, let me show you how you can figure that out. So let's draw a basic triangle here, and let's make it super easy. You know what? We're going to do connect line right there. Let's just make it a right triangle. And let's just have it go right around the origin right there, right? So we've got our spots, our 3 little points right there, and we've got our x's and our y's, right? 1, -1. We got -1, -1. And then we've got our -1, 1. Okay. So we need to make a new triangle, and the scale factor is 4. Actually, it's 4.1, but for our purposes, right, we're just going to multiply it by 4. That's close enough. We just want to see what happens to the area and the perimeter. So let's multiply each x and y by 4, right? So if I multiply this x and y right here by 4, what that's going to get me is that's going to get me 4, -4, right? So let's draw that down here. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I'll put that point right there. We'll draw it in a little bit. If I multiply this by 4, right, then I'm going to get -4, -4. And so that's going to be -4, -4. And that's going to come 1, 2, 3, 4. Okay, so that's right there. Then if I multiply that by 4, right, that's going to be -4, 4. So -4, 4. And that goes right up here. All right, so let's actually connect those lines right here. All right, and we'll do some magenta right there. I've got my new spots. All right, so I've got my 2 different triangles. So let's check the perimeter real quick. So the perimeter of the inner triangle right here, right, that's, put it on draw, that's 2 right there. That's 2 right there. The hypotenuse we know is not exactly 2, but just for our purposes, let's say we get 2 diagonals, right? So triangle 1, we get the perimeter equals, let's call it 6, right? Let's see what happens to triangle 2. Well, it's 8 down here, it's 8 here, and then, you know, once again, for our purposes, the diagonal is 8, right? So it's 24. Well, you see the scale factor right there, right? So what happens with the perimeter when you are using a scale factor, it is a linear progression. That means you just take your perimeter 1, you multiply it by the scale factor, right? And you're going to get your 24. So you just multiply it by the scale factor. Perimeter is pretty simple like that. So what that means is we're looking at either A or C, because those 2 have the perimeter as 4.1 times. Those are the linear progression. Now let's look at the area, okay? So if we're looking at the area here, well, we could just count squares, right? I've got 1 square, 1 full square, and then I've got 2 half squares, so that makes 2. So the area of triangle 1, right, the area, that yellow is hard to see, so let's make it green. So the area is 2, right? Now the area of the other one is going to be a little bit more difficult. 1, 2, 3, 4, 5, 6, 7. You got 7 full ones, and then it goes 6, 5, 4, 3, 2, 1 full ones. And if you count all of these right here, right, you're going to get the area of 32. So how do we get from 2 to 32? Well, it's quadratic. You take your scale factor and you square it, and you get 2 times that 16, gets you to 32. So the answer is C.